Hello again, traveller. Tonight, you are quietly observing how water was collected, stored, and distributed in a medieval city, step by step, system by system, from the moment it leaves the ground to the moment it reaches the people who depend on it. Prepare to immerse yourself in this calm, detailed look at medieval water systems consisting of springs, intake works, gravity channels, cisterns, fountains, wells, and the routines that kept entire cities alive long before modern plumbing ever existed. Nothing dramatic, just water, stone, gravity, and human attention doing their jobs over time. And before you relax too much, take a second to subscribe to the channel, and ring the bell for notifications of new archival videos. Also, let me know in the comments where in the world you're watching from. Cities solve water differently, and it's always interesting to see where these quiet histories are being heard. Settle in. Let your mind slow down and allow the system to reveal itself. You stand outside the city walls, where the stone thins and the rules loosen, and where water exists before it becomes municipal. The ground slopes in a way that tells you where water wants to go. Low grasses bend toward dampness. Moss gathers where stone stays wet longer than it should. The city does not begin with pipes or fountains, it begins with attention. You observe men walking the land slowly, not in straight lines, but in arcs and pauses. They are not searching for water in the abstract, they are testing reliability. A spring that flows strongly after rain but disappears in late summer is noted and then rejected. A stream that looks generous but swells with silt during storms is marked as dangerous. A river is powerful, but power is not the same as usefulness. Rivers flood. Rivers carry waste from upstream settlements. Rivers are difficult to control. The city prefers water that rises on its own. A spring is favored because it emerges filtered, already cleaned by layers of soil and stone. You watch hands scrape away leaf litter to expose a trickle. The flow is measured by sight and by time. A vessel fills slowly, another fills faster. The difference matters. This is not about abundance alone. It is about consistency. A city can ration a small flow. It cannot manage a source that disappears without warning. The land around the source is evaluated next. You notice how close animals graze. You see where paths cross the damp ground. Human traffic leaves traces. Bare earth compacts. Waste follows people. If the spring lies downhill from any settlement, latrine, tannery, or burial ground, it is dismissed. Water remembers what touches it. Once a source is selected, the city does something subtle but critical. It claims the water before it moves. Stones are set into the ground, not to stop flow, but to mark authority. These boundary stones are not decorative. They define behavior. Washing is forbidden here. Slaughter is forbidden. Drawing water directly without permission is punished. The city understands that protection upstream prevents labor downstream. You watch the ground being cleared. Shrubs are cut back. The area is drained just enough to prevent pooling. The goal is not dryness, but clarity. Water must be visible as it emerges, so changes can be seen. A spring that clouds suddenly signals trouble elsewhere. Observation requires exposure. Rules are established, sometimes written, often customary. The keeper of the source is named. This person does not own the water, but they control access. They inspect after storms. They watch for footprints where none should be. They clear debris. Their authority comes from routine, not force. Neglect here is more dangerous than theft. Seasonal behavior is recorded mentally. In winter, ice forms around the margins. In spring, meltwater increases pressure. In late summer, the flow thins but should not vanish. If it does, the city has misjudged. This assessment takes years. A source is never fully trusted in its first season. Only after the source proves itself does construction begin. A crude head wall is raised, not to trap water, but to stabilize the emergence point. Stone is fitted carefully, mortar is used sparingly. Too much sealing forces water to find new paths. The city does not want to chase its supply underground. A shallow channel is scratched into the earth to guide the first controlled movement of water. This channel is temporary. It exists to test direction and slope. Water is allowed to flow. Its speed is watched. Where it accelerates too quickly, erosion begins. Where it stalls, sediment gathers. These observations shape the permanent works that will follow. Nothing bears resemblance to infrastructure yet. It is reconnaissance made permanent. The city does not rush. Once the source is altered, it cannot be unaltered easily. Every stone placed here commits future generations to maintenance. You remain still while time passes. The rain comes, leaves fall, and snow melts. The spring continues. Only now does the city decide that this water is worth the effort of capture. The system has not started yet, but it has been authorized. You now observe the moment where intention becomes structure. The city approaches the source again, this time with stone, timber, and tools shaped for repetition. The goal is no longer observation. The goal is control without suffocation. The first structure built is not the intake itself, but the deflection. A low barrier is set slightly upstream, angled across the flow. Its purpose is simple. It persuades debris to continue downstream while allowing a portion of clean water to be invited aside. The barrier does not span the full width. It creates choice in the current. Stones are selected for weight, not beauty. Flat faces are turned inward. Gaps are minimized but not eliminated. Water must move freely, or pressure will undermine the base. The barrier sits low enough that floodwater overtops it rather than destroys it. This is a structure designed to lose gracefully. Behind the barrier, the intake mouth is formed. You see a small opening, stone-lined, set at a height that avoids drawing the very bottom of the flow where grit travels. The opening is narrow. This limits volume intentionally. A city prefers predictable scarcity over chaotic abundance. A grate is placed over the mouth. In wealthy cities it is iron. In others it is carved wood. Either way it is removable. Fixed barriers fail quietly. Removable ones fail visibly, which is preferable. The spacing of the bars is chosen to block leaves, twigs, and small animals without stopping flow. Immediately upstream of the intake mouth, the channel widens and deepens. This is the settling pocket. Here, water slows. Sand, grit, and heavier particles drop out of suspension. You watch as the pocket fills slowly over weeks. This is expected. Accumulation here prevents accumulation elsewhere. A bypass channel is cut to one side. During heavy rain, when the pocket threatens to fill too quickly, excess water spills into the bypass and rejoins the stream. This prevents silt from being forced into the intake by volume alone. The bypass is not elegant. It is practical. Control is added next. A shut-off mechanism is installed, usually a vertical slot where a wooden board can be lowered. When the board is in place, water stops entering the system. This allows the pocket to be cleaned without draining the entire source. The board swells when wet, improving the seal. This is not precision engineering. It is good enough engineering. Markers are placed nearby. A simple staff shows normal water level. Another marks the depth at which cleaning is required. These markers are for humans, not water. They translate slow change into visible instruction. You observe the first cleaning. The board is lowered. Water backs up slightly, then spills into the bypass. The grate is lifted. Hands rake out leaves. Sediment is shoveled from the pocket. The bypass carries the dirty water away. When the pocket is clean, the board is raised slowly. A sudden opening would send a surge downstream, unsettling everything built later. This procedure becomes ritualized and somewhat habitual. Every keeper learns the order. Deviating from it creates problems that take days to diagnose. Stonework around the intake is reinforced last. The ground is armored against trampling. Edges are defined so water does not wander. The area becomes unmistakably managed. This discourages misuse. People behave differently around things that look intentional. The intake now performs a transformation. It takes water that belongs to the landscape and prepares it to belong to the city. It does not clean the water completely. That is not the goal. It removes threats that the rest of the system is not designed to handle. You watch water enter the opening, slowed, filtered, and measured. It does not rush. It does not stop. It behaves the same way every day. That is the victory here. The system is still fragile. Downstream structures do not yet exist, but the water has been convinced to behave. It will now accept direction. You remain fixed as the city turns its attention from the source to the space between. Water does not tolerate improvisation over distance. If the path is wrong, everything downstream fails quietly and expensively. This section of the system exists to prevent that outcome. The first task is not digging, it is measuring without instruments designed for precision. Men carry sighting poles and string. A shallow wooden trough is filled with water and set on supports. When the water inside rests evenly, the trough is level. This simple device is moved again and again across the terrain. Each placement confirms that the next step descends slightly, never rising. The slope is chosen carefully. Too steep and the water gains speed, scraping channels roar and carrying grit that scours stone and loosens joints. Too shallow and the water stalls, depositing sediment where it should not. The correct gradient allows water to move steadily, neither eager nor lazy. This slope is maintained across fields, through woods, and toward the city wall. Markers are driven into the ground along the chosen line. These stakes do not define the final path exactly. They define intention. Adjustments will follow as soil conditions and obstacles reveal themselves. The line curves when it must. Straightness is not a virtue here. Consistency is. The type of conduit is selected by exposure. Where the route runs open and protected, an uncovered stone channel may suffice. Where carts cross or animals pass, the channel is roofed. Where space is tight or contamination risk rises, pipes are used. Each choice is local. The city does not standardize when conditions do not permit it. You watch trenches being cut. Depth is dictated by frost, traffic, and slope. The bottom is leveled and compacted. A bed of sand or fine gravel is laid to cushion the conduit. This prevents point pressure that would crack stone or ceramic over time. Stone channels are assembled first. Flat stones form the floor. Side stones rise just high enough to contain flow. Capstones are placed above, leaving no gap wide enough for hands or refuse. Mortar is used sparingly. Water must not be sealed into a rigid box. It must be guided, not imprisoned. Where pipes are used, ceramic sections are aligned with the socket facing downhill. This orientation prevents leakage under pressure. Joints are sealed with lime mortar or pitch. Excess is wiped away. Smooth interior surfaces matter. Roughness creates turbulence. Turbulence invites sediment to settle. Access points are installed at intervals. Small openings, covered and flush with the ground, allow inspection and cleaning. Their placement is intentional. They align with straight sections, so tools can reach obstructions without excavation. These openings are not decorative. They are admissions that failure will occur. When the conduit crosses roads or paths, additional protection is added. Stone arches span the trench. Weight is transferred sideways and not downward. The city understands that traffic will increase over time. The waterline must outlive its surroundings. Backfilling is done in layers. Each layer is compacted. Loose fill settles unpredictably. Settling bends channels and cracks joints. Care within the system saves decades of repair. The route is marked above ground. Subtle stones, notches in walls, or changes in paving indicate where water runs below. This knowledge is passed on. A forgotten conduit is a doomed conduit. Once assembled, the line is tested. Water is allowed in slowly. Flow is observed at access points. Any surge, hesitation, or unexpected sound is noted. Adjustments are made before the system is committed to daily use. You watch the water travel the full distance for the first time. It arrives at the city boundary without drama. That is success. The line now exists. It will demand attention forever. You remain where the conduit approaches the city, where problems like to hide. This section of the system does not move water forward. It prevents it from stopping. The first structure you see is a sand trap. The conduit widens and deepens here. Water slows. Particles that survived the intake finally lose momentum. They settle on the floor of the chamber. This accumulation is expected. It is not a flaw. It is containment. The chamber is roofed and accessible. A cover stone can be lifted. The floor slopes gently toward a low point. Sediment gathers where it can be removed easily. The city has learned that spreading dirt is worse than concentrating it. Downstream from the sand trap, a flush chamber is built. This is a small cistern connected above the conduit with a gate at its base. Water fills the chamber slowly through a narrow feed. When full, the gate is opened suddenly. A surge rushes into the conduit, scouring its walls and floor. This action is deliberate and infrequent. Too much flushing erodes joints. Too little allows build-up. The timing is based on observation, not calendar. The keeper listens to the sound of flow at known points. Changes in tone indicate trouble. Rodding points are placed along the line. These are straight alignments where tools can be inserted to dislodge obstructions. The city does not wait for blockages to reveal themselves by absence of water. It probes preemptively. Maintenance roles are defined. One person watches daily. Others are called monthly. Skilled hands are reserved for seasonal repairs. This division prevents fatigue and neglect. When everyone is responsible, no one is responsible. Leaks are handled carefully. A small leak may relieve pressure and seem harmless. Over time, it undermines the bed, shifts stones, and creates a sinkhole. Repairs are made immediately, even when inconvenient. Mortar joints are inspected. Lime degrades slowly in moving water. Repointing is routine. Wood sections are checked for rot. Replacements are prepared before failure occurs. Emergency work is expensive and disruptive. The system is tested after storms. Heavy rain carries unusual loads. The sand trap fills faster. The flush chamber may need to be used sooner. These responses are learned through repetition. You notice that none of this is hidden. Maintenance is visible. Covers are lifted, tools are used. The city understands that concealed systems are forgotten systems. Records are informal but persistent. Certain bends always clog first. Certain access points require more attention. This knowledge lives in people, not in parchment. It is passed by instruction and example. Water continues to move because people intervene before it stops. This is not automation. It is vigilance disguised as routine. The conduit now approaches the inner city. It is clean, steady, and controlled. The system is ready to be divided. You remain still as the water reaches the edge of the city and crosses an invisible boundary. Outside the walls, the system existed to protect water from the world. Inside, it must protect the city from water behaving badly. The conduit does not enter at random. It arrives at a controlled point, usually near a gate complex or service corridor where access is restricted and oversight is routine. This location is chosen because it can be guarded, inspected, and repaired without disrupting daily life. Water that cannot be reached cannot be governed. Here, the conduit opens into a distribution head. This is not a large structure. It is a junction box, sometimes little more than a stone chamber with multiple outlets set at different heights. The water pauses briefly here, not enough to stagnate, but enough to be divided deliberately. You observe how the outlets are arranged. Each one corresponds to a destination class, not a neighborhood. The city does not distribute the water evenly. It distributes the water by function. One outlet feeds public fountains. Another feeds institutional users. Another feeds storage cisterns. The separation is intentional. Mixing users complicates control. Each outlet is governed by a simple device, a plugstone, a wooden stopboard, in rare cases a metal turncock. None of these are precise. They do not measure volume exactly. They allow water or deny it. Fine control is achieved through timing rather than mechanics. Pressure behaves differently here than it did outside the walls. Elevation changes matter more now. Friction increases as lines branch and narrow. Water reaches lower districts easily and struggles toward higher ground. This imbalance is accepted. The city does not attempt to equalize pressure everywhere. It adapts behavior instead. Trunk lines extend outward from the distribution head. These are larger channels or pipes that carry water toward districts rather than individual buildings. Their routes are conservative. They follow streets that are unlikely to be excavated deeply. They avoid latrine corridors. They stay close to inspection access. Where trunk lines intersect, additional control points appear. These are not for daily adjustment. They exist for isolation. If a line fails, it can be closed without draining the entire system. This prevents localized problems from becoming citywide ones. You notice something else that seems wasteful at first: overflow paths. At several points, excess water is allowed to escape intentionally into drains or open channels. This is not neglect. When demand drops suddenly, pressure must be relieved. Water that cannot move forward will find ways sideways. These overflows are routed carefully. They do not undermine foundations. They do not flood basements. They join existing drainage systems or are directed toward street cleaning channels. Loss here preserves stability elsewhere. Nothing about this distribution is hidden. The city wants its water routes known to those responsible. Secrecy breeds confusion during emergencies. Control depends on familiarity. You watch the system operate through the day. As demand rises, outlets are adjusted. As demand falls, water spills harmlessly away. The city does not chase perfect efficiency. It chases predictability. The water now belongs to multiple paths at once. Each path is understood. Each can be altered. The system has entered its most complex phase, not because of technology, but because of choice. You continue observing as water is guided not toward people, but toward waiting spaces. Storage exists because cities do not consume water at the same rate they receive it. Night and day are unequal. Repair requires pause. Drought demands restraint. Storage absorbs these mismatches. Cisterns are placed where gravity allows them to serve without additional lifting. Elevation matters. A cistern too low only serves buckets. A cistern high enough can feed fountains and institutions without effort. These locations are chosen early and defended fiercely. Construction begins with excavation. The pit is dug wider than necessary. This allows space for lining and future repair. The floor is leveled and sloped slightly toward a drain point. This ensures that cleaning does not require heroic labor. Walls rise next, stone or brick set tightly. Joints are careful. Voids invite leakage. Once the structure is complete, it is sealed internally with layers of lime-based plaster. Each layer cures slowly. Rushing this step ruins the work. The inlet is designed to calm water. You see it enter through a side channel or deflection stone. Water is not allowed to fall directly into the cistern. Falling stirs sediment. Calm preserves clarity. The cistern is covered, light is excluded. Open water invites growth. Growth degrades taste and trust. Covers are solid and secured. Access hatches exist, but they are not convenient. Convenience here invites misuse. Water is drawn from above the floor. A pipe or opening sits higher than the sediment layer. This ensures that accumulated silt remains undisturbed during normal use. The bottom of the cistern is meant to be dirty. The top is meant to be useful. Overflow is planned. When the cistern fills, excess water exits through a defined route. This prevents pressure on walls and keeps the system balanced. Overflow water is not wasted blindly. It joins drains or secondary uses. Cleaning is procedural. Inlet closed, cistern drained, sediment removed, walls scrubbed, a fresh lime wash applied if needed. The first refill is partially discarded. This is understood. Cleanliness requires patience. Cisterns are not all the same. Some serve neighborhoods, others serve institutions. Some are emergency reserves, touched rarely. Their fill cycles differ. Their draw patterns differ. Each is managed according to its role. You watch time stretch here. Days pass. Water enters quietly. It waits. It leaves when called upon. Storage turns flow into availability. Without cisterns, the system would demand constant attention. With them, it tolerates human rhythm. The city rests more easily, knowing water is already where it needs to be, waiting. You remain in place as the system finally presents itself to the population. This is where water becomes visible and where failure would be noticed immediately. The city treats these points carefully because they are where technical systems meet human habit. Public fountains and standpipes are not scattered randomly. They are placed where foot traffic is already controlled. Near markets, parish centres, or gate plazas, people arrive with purpose. Water collection becomes one task among others, not a wandering activity that spreads congestion. Each fountain begins with a receiving chamber hidden behind the visible stonework. Water arrives here from a trunk line or cistern. It does not rush straight to the spout. It settles briefly, allowing air to escape and flow to stabilize. This prevents sputtering and irregular delivery. The spout itself is positioned deliberately. It projects far enough to allow vessels to be filled without touching stone. Contact spreads grime. The height accommodates standardized containers. This standardization is cultural rather than legal, but it matters. Predictable vessels prevent spill and crowding. Below the spout, a catch basin receives overflow. Its size is calculated to handle peak use without splashing. The basin is sloped gently toward an outlet. Water that misses a bucket does not linger. Standing water invites misuse and decay. Flow is regulated. Some fountains run continuously at a low rate. Others operate during fixed hours. In some cities, a keeper controls a valve. In others, timing is enforced socially. Continuous flow prevents stagnation but consumes supply. Timed flow conserves water but demands discipline. The choice reflects local priorities. Rules are posted or understood. Washing clothes is prohibited at the spout, so is cleaning meat or tools. Animal watering occurs downstream at designated troughs, fed by overflow. This separation protects quality without requiring constant supervision. You watch the queue form and dissolve. Approach patterns are consistent. People know where to stand, where to fill, where to leave. These patterns reduce conflict. They are not enforced by guards. They persist because disorder slows everyone. Maintenance is constant. Scale builds on stone. Algae forms where light reaches water. Basins fill with grit. Keepers scrape, scrub, and clear drains. Neglect here is immediately visible and quickly punished by public complaint. Overflow water is not ignored. It is directed into drains, street channels, or secondary basins. In some areas, it is used deliberately for street cleaning. Water serves multiple roles before leaving the system. You observe that these access points do not deliver convenience, they deliver reliability. The city accepts the labor of carrying water because the alternative is uncertainty. The system functions because people adjust to it, not because it adjusts to them. Public fountains are the face of the network. They are simple, durable, and honest about limits. They show exactly how much water the city is willing to give at once. You continue watching as water is diverted away from the public eye. Not everyone draws from fountains. Some users require volume, consistency, or timing that public access cannot provide. These users are accommodated carefully because their demands can overwhelm the system if left unchecked. Institutions negotiate access formally or by long-standing custom. Monasteries, bathhouses, breweries, and certain workshops receive allotments. These are not gifts. They are contracts measured in pipe size, flow duration, or fill cycles. A branch connection is created at a controlled junction. This junction includes a shutoff that belongs to the city, not the user. Access can be reduced or eliminated during shortage. The physical presence of this control enforces compliance more effectively than law. The branch line follows the shortest reliable route. Length increases friction and failure risk. The line avoids waste corridors. It is buried or enclosed to prevent tampering. Unauthorized taps are a known problem. Physical protection reduces temptation. At the destination, water enters a header cistern or distribution box. From here, it is allocated internally. A monastery routes water separately to the kitchen, infirmary, and garden. A brewery schedules water use around brewing cycles. A bathhouse fills heating tanks in sequence to avoid draw spikes. Wastewater is managed deliberately. Discharge does not return toward intake zones. Drains carry used water away from the system entirely. Reuse occurs only after distance and dilution. Inspection is routine. City representatives check branch lines for enlargement, leaks, or unauthorized outlets. Pipe diameter is a form of currency. Increasing it without permission is theft. Evidence is physical and difficult to dispute. During shortage, these branches are the first to be restricted. Public supply is preserved by design. Institutional users accept this because their privilege depends on restraint. Excessive use risks revocation. You notice that private supply does not mean isolation. These users remain embedded in the city's logic. Their water arrives because the system allows it, and it stops when the system requires it. This controlled privilege prevents fragmentation. Without it, powerful users would build independent systems, undermining shared infrastructure. By keeping them within the network, the city maintains authority over flow. Water in this setting serves specialized labor. It enables production, care, and ritual. It does so under conditions that preserve the larger balance. The system remains whole because every branch remembers where it comes from. You remain motionless as attention shifts away from the flowing network and downward into the ground. Wells do not replace the main system. They exist beside it, answering different problems with different mechanics. Where the conduit depends on slope and continuity, wells depend on depth and patience. Site selection begins with avoidance rather than attraction. Wells are placed far from latrines, burial grounds, tanneries, and refuse pits. The city understands contamination intuitively, if not scientifically. Water drawn upward carries with it the memory of everything above it. Distance is the only filter available here. Digging proceeds cautiously. The shaft begins wide to allow movement and light. As depth increases, the walls are shored with timber rings. These prevent collapse while stone lining is prepared. Excavated soil is examined. Dampness, clay layers, and gravel beds signal proximity to water. Sudden seepage is watched carefully. Too much too soon risks flooding the shaft. Stone or brick lining follows the dig downward. Rings are set tightly, joint by joint. Gaps invite collapse and contamination. The lining rises above ground level to form a curb. This curb prevents surface runoff from entering directly. Water must arrive from below, not from rain washing across streets. The opening is covered when not in use. Covers are heavy. They deter casual dumping and slow evaporation. Light is excluded as much as possible. Growth inside a well is difficult to remove once established. Lifting mechanisms are installed. The simplest is a rope and bucket over a pulley. More elaborate setups use a windlass or counterweighted sweep. Each system standardizes effort and volume. Buckets are sized consistently. This controls draw rates without measuring devices. Use is regulated by custom. Certain wells serve certain streets. During normal conditions, access is shared. During drought or siege, priority shifts. Wells near defensive positions or hospitals receive protection and scheduling. Disorder here would cripple morale as much as supply. Maintenance is manual and periodic. Sediment accumulates at the bottom. This reduces capacity and clarity. Workers descend to dredge it out. Ropes are replaced before failure. Wooden components are checked for wear. Neglect results in sudden loss, not gradual decline. Water bearers become essential here. Unlike the conduit system, which delivers to fixed points, wells require transport. Labor fills the gap between source and use. This labor is visible, noisy, and exhausting. It is tolerated because it preserves independence from the main line. You notice how wells change behavior. People conserve more when each vessel costs effort. Waste decreases. Awareness increases. Wells discipline consumption through fatigue rather than rules. The city values this redundancy. When conduits fail, wells persist. When wells are compromised, conduits compensate. Neither is sufficient alone. Together they form a resilient supply web that absorbs disruption. Wells do not move water forward. They wait for it to be pulled. That waiting is their strength. You continue observing as the system is tested, not by routine, but by disruption. This is where design intent reveals itself. Water systems are not judged by abundance, but by how they behave when abundance disappears. During drought, the intake remains open, but flow weakens. The city responds in sequence. Private branches are restricted first. Storage draw increases. Fountain hours shorten. Overflow paths are reduced. Wells see heavier use. These changes are reversible. This is a function that matters. When heavy rain clouds the source, the intake gate is closed deliberately. Water in the settling pocket turns brown. It is allowed to pass into the bypass instead of the system. Cisterns carry the city through the pores. This is why they were built. Freezing conditions alter behavior again. Exposed channels are insulated with straw and boards. Flow is maintained at a trickle to prevent ice formation. If freezing persists, distribution shifts toward wells. The system flexes rather than resists. Fire demands immediate redirection. Trunk lines are opened fully toward firefighting basins. Ordinary drawers are suspended. Storage empties rapidly. Refill follows once danger passes. Everyone understands this priority without explanation. Siege changes everything. If the intake lies outside the walls, it may be abandoned or sabotaged deliberately. The city falls back on cisterns and wells. Access is guarded. Rationing becomes strict. Maintenance continues, even under threat. A broken pipe is more dangerous than an enemy arrow. Contamination suspicion triggers isolation. Gates close. Sections are flushed. Wells substitute. Trust is preserved by visible action. Doing nothing invites panic. After a crisis, restoration follows order. Intake is inspected. Traps are cleared. Cisterns are refilled. Public access resumes before private. Normal flow returns gradually. Sudden abundance causes damage. You notice that nowhere does the system rely on speed or force. It relies on sequence. Every response has a place. Every control has a reason. The system survives because it was never designed to be invisible. It expects human attention. It requires judgment and rewards patience. You remain where you are as water resumes its ordinary behavior. Flow steadies, labor eases. The city returns to routine, not because the system is perfect, but because it is understood. Nothing in this city is symbolic. Every stone, slope, and pause exists because someone learned what happens when it does not. The water continues, and the system holds. Well, traveller, you have now watched an entire medieval water system do what it was built to do. There were no speeches, no heroics, just careful choices, constant maintenance, and gravity behaving exactly as expected. If this kind of slow, detailed, quietly fascinating history helps you relax, fall asleep, or just think a little more clearly, go ahead and like the video, subscribe to the channel, and ring the bell so you don't miss new releases from the archives. There's plenty more quiet work where this came from. Thank you for spending your time here, traveller. Rest easy.